we have linear differential equation with constant coefficient. So on this equation is the second order differential equation. So first we will write the auxiliary equation. Because it is second order, the auxiliary equation will correspond to a quadratic equation. So the coefficient will stay the same. We have 1 here, so that's just r squared plus 4r plus 4 equal to 0. And now we will solve for it. This is r plus 2 squared equal to 0. So we have r equal to negative 2. Note that because we have the factor of 2, I should say power of 2, then this is multiplicity of 2. Or we say the repeated root. So we will have this situation of repeated root, and this is y1 and this is y2. Y1 is e to the rt, y2 is t e to the rt. Because the solution have to be linearly independent, we have to have the t multiplied to it, so it will be linearly independent. Let's say if this is multiplicity of 3, then we will have y3 equal to t squared e to the rt, and then so on. So the solution must be linearly independent, and if we only have one of them, we generate uh, the linearly independent solution by just multiplying t to it. Right. So we will have y1 equal to e to the rt e to the negative 2t, y2 t e r t t e to the negative 2t. And the linear combination of them is the solution c1 y1 c2 y2. So c1 e to the negative 2t, c2 e to the, I forgot the t, and that's what we have. That is the general solution. However, in this problem we have to solve for the initial condition. We have two initial conditions corresponding to two coefficients. That is C2, sorry. So we use that initial condition, two of them, to solve for these two coefficients. So first, we have y of 0 equal to negative 3, meaning that when t equal to 0, y equal to negative 3. And I'll substitute that into this equation. Negative 3 equal to c1 e to the negative 2 times 0 plus c2 e, I forgot the t again, c2 t is 0 e to the negative 2 times 0. Because we have 0 here, so that one go to 0, and e to 0 power is 1. So pretty much we will have just negative 3 equal to c1. So that is c1. Now we will need to solve for c2. We don't need the formula anymore, so let's just do this. Now we have the function, but we do know c1 is negative 3, so y is going to be negative 3 e to the negative 2t plus c2 e to the, I forgot the t again, e to the negative 2t. We will take derivative before we use the condition because this we have the derivative. So derivative is going to be negative 3 e to negative 2t. The chain rule, we should have negative 2 e to negative 2t. And this is a product rule. And we use the product rule, we should have c2 e to the negative 2t plus c2t negative 2 e to the negative 2t. Right? Let's simplify this a little bit. We have e6 e to the negative 2t plus c2 e to the negative 2t minus 2 c2t e to negative 2t. Right? Now we can substitute this condition. The derivative is equal to 4 and t is equal to 0. And this goes to 0 because we have 0 here. E to 0 power is 1 and this is 2, also equal to 1. Right. So we have 4 equal to 6 plus c2. Because of that, c2 has to be negative 2. And with that, substituting the equation, we have y equal to c. The equation, of course, is going to be this one. c1 we know is negative 3 e to the negative 2t, and c2 we have negative 2 e, I forgot t again, negative 2 t e to negative 2t, and that's what we have.